In this inverting op-amp configuration with a current source, we're asked to find the resistances as seen inside these three nodes. Also, we are asked to find how much is the currents that flow upwards here in these nodes, and how much is the voltage here also. Let's go. To find the input resistance, we must set all independent sources to 0, so the current source becomes an open circuit and the voltage source over here becomes a short to the ground. Now I'm going to connect a voltage source. I'm going to name it Vx, and I'm going to measure Ix in respect to Vx in order to find R1. This current will flow all the way to here, but when it reaches this point, it cannot really flow inside the input of the op-amp, and it cannot really flow over here because it cannot close the circuit. That means that this current must be 0. 0 current means that R1, which is Vx over Ix, Ix is 0, therefore R1 must be plus infinite. Alright, so this is infinite. Now we want to find in R2, I'm going to do the same thing, set all independent sources to 0 and then connect a voltage source over here. Now, things are very easy here because the current, as we showed previously, cannot really flow over here. That means that this Ix is going to flow all the way to this point. I'm going to call this A, and the voltage here VA, and then it's going to flow into the ground. And then it's going to close the circuit over here like this. That means that these two resistances are in series. The input resistance R2 is going to look like Vx minus 0, right, the voltage here at the ground, over Ix, which is going to be the same as R over 2 plus R. So these are in series and are basically the input resistance seen over here. This is basically 3 over 2 R. Now, on to finding R3, I'm going to notice that these two resistances are in series and both of them are in parallel to this resistance. And then all of these are in series with R over 2. Alright, why? Because no current flows over here inside here. So since no current flows over here, this is basically like an isolated circuit. Alright? Vx over Ix, which is R3, is R over 2, this one, plus R in parallel to R over 2 plus R. Hope this is clear. And now we must do some quick maths. So R3 is 11/10 R. On to calculating these currents and voltages, well, I noticed that this current source forces a current all the way to here, and then this current goes all the way to here. That means that this current is going to indirectly force a voltage on this point, this voltage V1, because it forces a current to go through a resistor. That means that the voltage here, how much is the voltage here, by the way? This is a virtual ground. Why? Because the point here and the point here have the same voltage of 0. Why? Because this point is grounded. And because the op-amp is ideal, that means that this point is going to have the same voltage as this point, which is 0. Now, I'm going to take Ohm's law for this resistor over here. I'm going to say that for this resistor, the voltage difference from here and here, which is 0 minus V1, it's going to be over I. That means that this V1 is going to be nothing but... Alright, now how much is this current? Now it's easy to see how much is it, because this voltage here is the same as this voltage here. And if I take Ohm's law again for this resistor, I can say that R is going to be equal to the voltage here minus the voltage here, because the current flows upwards. So it's going to be 0 minus V1 over, how much is the current? I1. That means that I1 is going to be equal to minus V1 over R. And how much is V1? It's minus R times I over, with minus in front, over R. This gets simplified and it is plus I. Alright, this is I1. So we found I1 also. Alright, now we know I1, we know the voltage here, and we need to find the voltage here and the current over here. Now we know that the current flowing all the way from here to here is going to be how much? I plus I. We see why? Because I goes inside, I also goes inside. Remember, I1 is I. Therefore, this current will be 2I. Okay? This current flows from here to here, and we're going to take Ohm's law again for this resistor R2. R over 2. R2 is going to be equal to V1 minus V2 over the current, which is 2I. This is I. Alright. How much is V2 then? V2 is going to be equal to, this gets simplified. This is V2. Okay, we found V2. Now, again, I'm going to do the same thing to find this current, I2, like I did before. Alright, Ohm's law, again for this resistor. 0 minus V2 over R. It's going to be I2. That means that I2, it's going to be, how much is V2? Minus minus plus 2R, 2IR, which is 2I. Okay? Alright. Now I know that I2 is 2I, and I have 2I and 2I going both of them inside this node, which means that when the current, the total current that exits here is going to be how much? 4I. Therefore, that means that I3 is going to be nothing but minus, right? Because it's the opposite way, 4I. How much is going to be V3? Well, for V3, I'm going to do the same thing as before. I'm going to say that taking Ohm's law, it's going to be V3 minus V2 over R over 2 is going to equal to I3. If you do the math, V3 is equal to 0 volts. Alright, check out the op-amp playlist over here for more op-amp exercises and videos. Study well and take care. Bye-bye.